All right, this video we're going to look at rational expressions. We're going to find the domain. We're going to learn how to reduce them. We're going to add them, subtract them, multiply, divide, and we're going to simplify complex fractions. So let's go ahead and get started. So first, let's look at finding the domain of a rational expression. So to find the domain of a rational expression, we know that if we have a fraction, we cannot have 0 in the denominator. So in this case, these rational expressions, the only thing we have to look for is when is the denominator 0. Now, in maybe a more advanced class or something like that, or if you're doing more difficult problems, you might have like a radical up here in the numerator, something like that, and then you would have to do some other stuff. But for these problems, it's basically when is the denominator 0, and the domain is everything but those numbers. So for this one, we want to know when is the denominator 0. Well, obviously you can see that would be -3. But all you're doing is you're taking the denominator, this x plus 3, and you're setting it equal to 0, and then you're solving for x. So if we subtract 3 to both sides, we get x equal -3. So the domain is everything but -3. Now, how do we write that? How do we write the domain? Well, I'm gonna write the answer two different ways. Some books may write it one of the ways. Other books might write it the other way that I'm going to write the answer. But I'll write it both ways, and so you can see it. So the domain is everything but -3. So one way that we could write the answer is that it's the set of all x. These are braces right here. So it's the set of all x such that x does not equal -3. So this is one way that we could represent the domain. And the other way that we can represent the domain is we can put it in interval notation. So I think the easiest way to write the interval notation is if you look at the number line and just put the -3 here on this number line, and the domain is the entire number line, everything on the number line except -3. See, if we were graphing it, it would be everything except -3, and that's why there would be a hole there in the graph there. So the way we would write this is it's everything from -infinity up to -3. And this would have a parenthesis on it because the -3 is not included. So that took care of this part of the line. Then we've got to jump over here and write this interval. And that would be or union. That would be from -3 to +infinity. All right. And that's another way that you could write the domain of that function. Now, how do you write it? I don't know, however your teacher wants you to write it. Actually, the book that I'm teaching out of, it writes it this way. And I've seen it where some books write it like this. All right, so let's take a look at the next example. So we want to know when is the denominator 0. So we're just going to take the x squared plus 5x plus 6 and set it equal to 0. And then we'll have to factor it. So that's x plus 3, x plus 2. And then we set each factor equal to 0. X plus 3 equals 0 or x plus 2 equals 0. And then we solve each one individually. So x equal -3 or x equal -2. So the domain is all real numbers except for -3 and -2. So we could write that as the set of all x such that x does not equal negative 3 and x does not equal negative 2. All right. So that's one way. Now the other way, just like I did here, the interval notation. Let's just plot both numbers on the number line, and the domain is everything except for those two numbers. All right. And this number line here, you don't have to draw that. I just draw it because I think it makes it easier to write it in interval notation. I've just got to write down this interval, and this interval. So that's going to be negative infinity to negative 3, union negative 3 to negative 2, union negative 2 to infinity. And this is your answer. All right, now let's look at the last one. So I've got x squared plus 9 in the denominator. So when is x squared plus 9 equal to 0? Okay. Well, if I go to solve this, I get x squared equals negative 9, right? If I move the 9 over. Well, you can't take the square root of a negative number. If you do, it's an imaginary number, okay? Now, you may not know that just yet, but that's coming up in the next section or two, on the section on complex numbers. So you'll see it there. But another way to look at it is, in order for this to be 0, hopefully you can understand that x squared has to be negative 9, right? Negative 9 plus 9 is 0. So what can I square to get negative 9? What squared? What real number? Well, if I put a 3 in there, 3 squared is positive 9, so that doesn't work. And what about negative 3? Well, negative 3 times negative 3 is positive 9 also. So that's not going to work either. So there's nothing that I can square to get negative 9. So there's nothing that will make that 0. That denominator will never be 0. So my solution, my domain, is the set of real numbers. And that's one way that you can represent the real numbers, is with that R. Okay. So that's one way to do it. And then let's put it in interval notation. Well, the interval notation, that's what? That's every number, right? That's all real numbers. So that's every number on the number line. So that would be negative infinity to positive infinity. And that's the two ways that you could represent it. All right. All right, now let's look at reducing these rational expressions. So we want to reduce these to lowest terms. It's kind of like, it's like what you did here. If you added or subtracted or multiplied fractions and you ended up with something like this, well, you would have to do what? You would reduce it to 3/4, right? That's exactly what we're doing here. It's just we have polynomials. Okay, we've got rational expressions here. All right, so the first thing you do whenever you're reducing a rational expression, if you can, you factor it. You factor everything, okay? So let's look at the first one. So if you look at the numerator, I can factor out the greatest common factor. So I factor a 2 out here, and then this factors into x plus 2 times x plus 3, all right? And then whatever's in the numerator can be canceled with whatever's in the denominator. So you see here the x plus 2's can cancel. And so that's going to leave me with 2 over x plus 3. All right. All right, let's look at this next one. Well, b minus a, I can't factor anything there. So I'm just going to leave it b minus a over. Now this is the difference of two cubes. All right. So the previous video, I believe it was, the previous video on factoring, I go over how to factor the sum and difference of two cubes. Okay, if you don't want to watch that whole video, go to my channel. I have a video just on factoring the sum and difference of cubes. All right, just search for it on my channel and you'll find it. So this, I've got a minus b. So all you do is just drop the exponents and write this down. And then you square this term, change the sign, multiply them, always positive, and then square the last term. Okay? And that's the denominator factored. All right? Now remember, at this point in college algebra, it's assumed you know how to factor already. Okay? But like I said, go watch the video if this is confusing you. All right, now let's cancel. So this is going to cancel into 1 and negative 1. All right, so you might be thinking, how in the world did you get that? The negative 1 and the positive 1. Well, these are what we call opposites of each other. All right. Now, what I'm going to do is I'm going to take just this part right here. Okay? The b minus a over a minus b. All right? And I'm going to show you how when we cancel it, we get negative 1 and 1. All right? I'm going to work it all out so you can see it step by step. But what I'm fixing to do here, you're not going to show all that work, okay? You're just going to be able to recognize that these are opposites, and you know that they're going to cancel into negative 1 and 1, okay? And I'll explain a little more how to tell if they're opposites. But let's look at this first. So if I look at this, we can, in this numerator here, we can factor out a negative 1. And if we factor a negative 1 out, all that does is change the sign of each of those terms. And that's over a minus b. And then writing this negative 1 times, and then I'm just going to reorder these. Okay. And then you can see that this and this cancel. I'm left with 1 and 1, right? And so look at this. Negative 1 times 1 is negative 1, and then that's 1. And that's where the negative 1 and the positive 1 come from. Okay? Now, let me say this. If you wanted to, when you cancel these, you could call this negative 1 and that one positive 1 up there. It doesn't matter. The way this would work, instead of factoring a negative 1 out of the numerator, we would factor the negative 1 out of the denominator. Okay? Same thing. It's just when I notice that I have opposites and I'm canceling, I just always put the negative 1 in the numerator. Okay? Why do I do that? I don't know. I just do. Okay? I'd rather have the negative in the numerator than the denominator. I guess that's it. Okay? All right. So hopefully that made sense and you can understand why it's negative 1 and 1. Now, this part that I'm erasing right here, let me restate. You're not going to have to show all that. Okay? Well, let me take that back. If you're in my class, you don't have to show all that. Some teachers may make you do it, but I know I don't. Okay? So what we're looking at here, we had b minus a over a minus b. And I recognize right off that these are opposites of each other. So how do we know? Well, look at this. You see the number in front of the sign in front of a and this. See, this is understood to be positive. You see how the sign in front of each one's opposite, and the sign in front of each of the b's, they're opposite also? That lets you know those are opposites of each other. Okay? Now look at this. X minus 2 over x plus 2. Just look at that. Now, you see here how the sign in front of the 2's are opposite, but look at this. The sign in front of the x's are not opposites. So this, not opposites. So that means they don't cancel into -1 and 1. The sign in front of both have to be different in order for them to be opposites. Okay? All right. Now that we've canceled this, so this is going to leave us with what? -1 over a squared plus ab plus b squared. And there's your answer. All right. Now let's look at this one. Let's cancel. So I've got x squared, x to the 5th. Well, this exponent's going to cancel into a 1. This one's going to cancel into a 3. Let me actually write that 3 maybe right here. This is going to cancel. That's just going to take that out, and this is going to cancel into a 2. And so we get what? We get, I'm sorry. I messed up there, didn't I? This x squared here, that's just going to cancel that one, and we're left with x cubed. This x squared's completely gone. So that is going to leave me with z squared over x cubed. Now, it kind of goes back to that lesson on integral exponents, where you're subtracting exponents, that kind of stuff. So basically what we have here, let's just take this problem, x squared z cubed over x to the 5th z. And let's just write this out. Okay, so remember x squared is just x times x, z cubed is z times z times z, x to the 5th is this, and then the z. So basically all that's going on is, see how this z is canceling, and then this x and this x, this x and this x, and see here you're left with what? Z squared, and here you're left with x cubed. That's how that works out. But I mean, you're not going to write all those out. You're just going to subtract the exponents when you cancel. All right. So I hope all this made sense on reducing these rational expressions. If you understand how to reduce the rational expressions, then what we're fixing to do here next is going to be easy. Multiplying rational expressions, and then we'll do some dividing. All right, so let's look at multiplying rational expressions. So whenever you multiply rational expressions, factor everything. Okay, first thing you want to do, factor. All right, so factor out a 2. And let me say this before we go on. If you don't know how to factor, you've got to learn, okay? These problems here, if you don't know how to factor, you can't even start to work them, all right? Watch the previous video, College Algebra Factoring. I give a review in there. But if you need a more detailed review, if you go to the College Algebra Factoring and you look in the description, there will be 8 videos on factoring, and it goes through it in a lot more detail. It takes about 2 hours to watch all 8 of them, but it'd be worth it. All right, and so we've got a 6, and then times 9a over, and then this is the difference of 2 squares. That's a minus b times a plus b. And then once you have them factored, whatever's in the numerator can be canceled with whatever's in the denominator. So you can see here the 2 and the 6 cancel. I'm left with 1 and 3. And then look, the 3 and the 9 cancel. I'm left with 1 and 3. And then this a minus b and this a minus b cancel. And so I am left with 3a over a plus b. Okay. All right, so I hope all this is making sense, and hopefully you can see that multiplying these things is really no different than when we were reducing them. You're just factoring and then canceling what's on top with what's on bottom. Okay, let's look at the next one. So this is x minus 1 over, this factors into x plus 2 times x plus 2. Now, I know this one factors. This one actually factors into x plus 2 squared. So you might be thinking, well, why did you write it like that? Well, there's a lot of times when you factor that, you're going to want to factor it like this. But when I'm canceling things, reducing stuff, I like to write it all out because I think it makes it easier to cancel. You're less likely to make a mistake. Okay? And then that's times x plus 2 over x plus 3 times x minus 1. Then remember, anything in the numerator can be canceled with anything in the denominator. So we've got an x minus 1 that cancels, and we've got an x plus 2 that cancels. And so we're left with, this is what, well, let me go ahead and write it. That's a 1 and a 1 there. So that's going to be 1 over x plus 2 times x plus 3. And there's your answer. And then if you want to, if you want to, if you're all excited about working this and then you decide, hey, I want to go ahead and multiply that out too, you can do that. Either answer would be acceptable. Okay, you can fold that out and write your answer. It doesn't really matter. All right, now let's look at division. So division, just remember whenever you're dividing fractions, a over b divided by c over d is equal to a over b times d over c. All right, so all it is this divided by this, is this divided by, is this times, change the division to multiplication, times the reciprocal of that term. So whenever you're dividing, first thing I would do is change it to multiplication. Okay? And then look, just this one step right here, this one step, now you're doing what you did up here with multiplication. Okay? So if you know how to multiply, you should know how to divide. You've just got to do this one step first, change it to multiplication. So the 3 and the 9 cancel, and then the x's cancel. And so I'm left with, what is that, 3 halves. All right. Now let's look at this one. All right. First thing, change it to multiplication. So that's 4 minus x squared over 6 times 2 over x minus 2. All right, so we change it to multiplication, and now we factor everything. So that's going to be what? 2 plus x times 2 minus x over 6 times 2 over x minus 2. All right. This is the difference of two squares, this numerator right here. So now I've got the 2 and the 6 cancel. I'm left with 3 and 1. And then look at this. Did you notice those were opposites of each other? Okay. So we are left with negative x plus 2 over 3. And all I did, I just wrote the x first. Okay. And then the negative, I just put it out in front of the fraction. Okay, out in front of the entire fraction. Just remember this. Remember this. Negative a over b is the same thing as a over negative b, which is negative a over b. It doesn't matter where you put the negative sign. If you wanted to put the negative up here in the numerator and distribute, this would be the same thing. Okay. Both of those are the same. All right, so now that we're having a lot of fun up until now, We've done the easy part. Okay, reducing, domain, multiplying, dividing. Now we come to everybody's favorite, adding and subtracting these things. And I'm kidding when I'm saying everybody's favorite. This is the one students hate the most. All right, so if a over b and c over b are rational numbers, then a over b plus c over b is a plus c over b, and a over b minus c over b is a minus c over b. Basically what this is saying is whenever you're adding or subtracting, in order to add or subtract, you got to have a common denominator. Okay? So whenever you have a common denominator, you can just add or subtract the numerators and put it over that common denominator. So let's look. So the first problem we've got here, well, we already have a common denominator, don't we? So we can just add the numerators and put it over the common denominator. And yes, if you want to, you can just go ahead and put 8. You don't need to show 3 plus 5. Okay, I'm just doing it for you. So you can see what's going on. So that's 8 over 2x plus 4. And then what? Now we got to reduce it if we can. Okay? Because remember, if you're adding or subtracting fractions and you get an answer of, say, like 9 over 12, then you would have to reduce it to 3/4, wouldn't you? Well, that's the same thing here. We've got to reduce these things. And so, let's see, that's 8 over 2 times x plus 2. And when we cancel, we're left with a 4 and a 1. And so that is going to be 4 over x plus 2. All right. Now, I know this looks very, very tempting right here. And believe me, I have seen it before where students want to cancel that 4 and that 2. And you cannot do that. If you're going to divide 2 into them to cancel, you have to be able to divide the 2 into all 3 terms, the 4, the 2, and the x. Okay? So this is your final answer. That can't be reduced anymore. All right, so let's look at this one. So first, let's see, do we have a common denominator? No. So what we've got to do before we get a common denominator is we need to factor the denominators. All right, factor the denominators. So now we get a common denominator. Let's see, I'm going to go down here and write it. All right. And my common denominator, well, I'll tell you what, let's just go through it. I'm going to go through it and show you how to get the common denominator. And let me say this. When I explain how to get the common denominator on this problem, and it may be a little confusing, you may not quite understand it. Say, well, I still don't quite understand how you got that common denominator. Wait till I get to this problem, and I think it'll make more sense on how to find the common denominator. Okay, I'll go through this. I'll explain it just like I did up here. But a lot of times when you have the simpler problems, sometimes it's harder to see what's going on. But let's, hang with me on these two. All right, so what we do is we look at each different factor in the denominator. We got an x minus 1, we got an x minus 1, we got an x plus 1. So let's look at the x minus 1. How many times does the x minus 1 appear in this denominator? It appears 1 time, right? And how many times does the x minus 1 appear in this denominator? 1 time. What's the most number of times it appears in one of them? Once, right? So we use it 1 time. Then we go to the next different factor, the x plus 1. Here it appears once. Over here it appears 0 times. The most number of times it appears in one of them is 1 time, so we use it 1 time. And so that is your common denominator, x minus 1 times x plus 1. All right, now that we have our common denominator, let's get our numerators. All right, so look at our common denominator. What do we have to multiply to this denominator to get our common denominator? An x plus 1, right? So that means we have to multiply the numerator by x plus 1. Now, what do we have to multiply to this denominator to get our common denominator? A 1, right? So we multiply 1 times that numerator. And so then that is going to give me x times x plus 1 plus 2x plus 3 over x minus 1 times x plus 1. All right. So remember, once you have the common denominator, you can add the numerators. And look, I wrote x times x plus 1. If you wanted to, you could have distributed that and put x squared plus x there. That's fine. Okay, I just chose to write this, and now I'm going to distribute the x. And so that's x squared plus 2x plus 3 over x minus 1 times x plus 1. And then we just combine like terms. So that's x squared plus 3x plus 3 over x minus 1 times x plus 1. Okay. Now, once again, we need to see if we can reduce this thing. Okay, does it simplify? Well, if you look at the numerator, the numerator, it doesn't factor any. So there's nothing we can do with it. And yeah, if you wanted to, you could multiply that out. I would just leave it factored out like that. Okay. All right, now let's look at this one. So first thing we want to do is factor. So that's x plus 3 times x plus 3. And yes, I know that's x plus 3 squared. If you want to write it like that, that's fine. I just think when you're dealing with problems like this, it's easier to leave it factored out like that. All right, and that's x, and that is x minus 3. All right, so now we got to get a common denominator. All right, so let's look at each different factor. Let's look at the x plus 3s. How many times does the x plus 3 appear in this denominator? Twice. How many times does it appear in this one? Once. What's the most number of times it appears in a denominator? Twice. And so we've got to use it twice. And then we look at the x plus 2. Here it appears once. Here it appears 0. The most it appears in one of them is 1 time. So we use it 1 time. So hopefully that cleared up getting the common denominator. Hopefully you understand how to find it now. And so there's our common denominator. Okay. Now, what do we have to multiply to this denominator to get our common denominator? You can see that's x plus 2. And what do we have to multiply to this denominator to get our common denominator? Well, that would be what? We need another x plus 3, don't we? So that's x minus 3 times x plus 3. Now, remember in this previous problem, what did I do? When I went from this step to this step here, I didn't multiply this out, right? Okay. I just kept it like this and then put it over there, and then I distributed in the next step. And that's fine if you want to do that. Another thing you can do, you can actually do this. You can go ahead and multiply them out before you even put it over the common denominator. Okay. So you can do that right there if you want to. Okay. So now let's subtract the numerators and put it over the common denominator. So that's going to give me x squared plus 2x minus x squared minus 9 over x plus 3, x plus 3, x plus 2. Now, can you see where my mistake is? Pause the video and look at this step right here and see if you can see where I went wrong. All right, so where did I go wrong? Remember, it is this minus that, right? Minus all of this. That has to go in parentheses. Don't leave the parentheses off. Okay? So now I've got x squared plus 2x, and now I'm going to distribute the negative. And that's x plus 3, x plus 3, x plus 2. Combine like terms, I get 2x plus 9 over x plus 3, x plus 3, and x plus 2. And this is your answer. And yes, you would check to see if you can reduce this. The numerator doesn't factor, nothing cancels, so that would be your final answer. Okay. All right, we're almost finished. We got just a few more to do. So this one is simplifying complex fractions. All right, so there's actually two ways to simplify these complex fractions. There's two ways to do this. I'm going to show you one of them. I'm going to show you the easier way to do it. Okay, the less confusing way, I think. All right, so first thing we want to do is let's look at everything as a fraction. So I just put the 4 over 1 there. Now, what I want to do is I want to look at each denominator. And I want to get the common denominator. So I look at the 6 and the 4. What's the common denominator of 6 and 4? That's right, 12. Then, what's the common denominator of x and x squared? Well, just to give you a little hint, whenever you're dealing with variables like this, it's the one with the largest exponent. And so it's 12x squared. And so what I want to do is I want to multiply each term by the common denominator. So that's going to be times 4 over 1 minus 12x squared times 3 over 4x. And then that's 12x squared times 1 over x squared minus 12x squared times 1 over 6. All right. Looks confusing, but it's not. The only thing I did is I wrote 12x squared next to each one of these terms. That's all I did. Okay. Now, let's start canceling. See how the x and the x squared cancel? I'm left with x, this, and this. I'm left with 3. And then the x squared and the x squared cancels. And then the 6 and the 12 cancels, and I'm left with 2. And so this is going to be what? 48x squared. 4 times 12. It's 48, and then the x squared. Minus, and then let's see what we got. Minus 9x. 3 times 3. Over, the x squareds are gone, so that's 12 minus, and then that's going to be 2x squared. All right. Now, you could do a little more to it, but there's really no need to. Of course, we've got to see if it reduces, right? Let's see if it reduces. Well, does anything factor out? Yeah, a 3x factors out of this, right? 3x, and that would leave me with 16x minus 3 over, and then a 2 factors out of that. That's going to be what? 6 minus x squared. Does anything cancel? Nothing cancels, so this would be your final answer. If you wanted to, you could leave it like this. That would be fine too. But I mean, I could see that this wouldn't cancel anymore without having to factor it. And if you can do that, okay, if you can do that, then there's no need to factor it. But if you can't see it, go ahead and factor it out like I did there, just to see if anything cancels, okay? All right, so let's look at this next one. All right, so first thing I want to do to solve this one is, well, I'm going to solve it the same way I did this one up here, but I notice here that I've got x plus 6. I've got this x squared minus 9 that I can factor out, okay? If you have any denominators that can factor, factor them first. And that is over x minus 3 minus x plus 4 over x plus 3. Let me change. That's not a very good looking plus sign. All right. So now let's get the common denominator. So we're getting the common denominator of this, this, and this. And we went over how to do that and when we were adding and subtracting these things. All right. So there's my common denominator. And all I'm going to do is I'm going to multiply the common denominator by each term. Okay? Now, you know something? I was actually going to write all this out, and then write this over, and then the common denominator, and then I was going to write this term here, and then minus x plus 3, x minus 3 times, and then this term. That's a lot of writing, isn't it? How about we do this? Let's be lazy about it. How about that? What am I doing? And hopefully you can see how easy this next step is. What am I doing? I'm multiplying each term by the common denominator. All I have to do is write the common denominator next to each term. That's all I'm doing. Multiplying each term by the common denominator. So look at this. What cancels? Well, they both cancel here, don't they? Here the x minus 3's cancel. Here the x plus 3's cancel. So I'm left with what? X plus 6 over, see, those cancel. And I'm left with just the x plus 6. That's going to be what? X times x plus 3. See, x times x plus 3 minus, and then I got x plus 4 times x minus 3. And you can see once we multiply each term by the common denominator, it's easy. Okay, now we just distribute this and fold this and combine like terms. And so that's going to be x plus 6 over x squared plus 3x minus x squared plus x minus 12. Okay. Now, once again, I messed up again, didn't I? Do you see where I messed up? It's minus the whole thing. Do not forget the parentheses. Students forget it all the time. Now, I can distribute the negative. So this is going to be x plus 6, x squared plus 3x minus x squared minus x plus 12. And so what do we have? Combine like terms. That's x plus 6 over 2x plus 12. All right. Let's see if it reduces. Can't forget to do that. X plus 6 over 2 times x plus 6. Look at that. Cancels. And so we're left with 1/2. All right. All right, so we got this problem and we got two more problems. So, I mean, if you've watched this far, don't stop watching now. You've come too far to stop now. All right. So with this problem, I'm going to do the same thing. I'm going to get a common denominator, multiply each term by the common denominator. But what I'm going to do right now is I'm going to rewrite this thing. And I want you to pay attention while I'm rewriting it. And I want you to see if you can figure out why I'm writing it the way I am, if you can understand what's going on, and just think about it while I'm writing it down, and then I'll explain how I get it. All right, so there we go. So I've got it rewritten. So first thing you probably notice is instead of 2 plus x, I've got x plus 2. I just swapped them, okay? Just so it would look like this one. Those are the same thing. This is how the problem's written in the book. And other books probably do that too. Why do they do it? Probably to try to confuse you. Okay, you know how us math people are. That's all we try to do is confuse the students. Okay, no, I'm just kidding. So, but yeah, I just wrote it to look like this one, that's all. Now, this one, the 2 minus x, and rewrote it as x minus 2. So, let's just take this part. You already know how to do this because I explained it earlier. It's a little bit different, and that's why I'm going to go over it again. Let's just take this part, the minus 4 over 2 minus x. And how in the world did I get that? Well, I noticed that this one and this one, the 2 minus x and the x minus 2, those are opposites of each other, right? Hopefully you notice that now. Okay, we went over it a while ago. All right, so this is the same thing as minus 4 over, and I'm going to factor out a negative 1, right? Factor out a negative 1. And then this, you see this negative and this negative, that makes a positive. And then I'm going to just rewrite this as x minus 2 with the x first. And that's where this term right here comes from. Okay? Now, all of this right here, are you going to need to show all that? No, you don't need to show it. I just showed it to you so you can understand why it's being rewritten like this. All right. Now, the simple way to tell you this, to go from here to here, is when you notice this and this, you notice that those are opposites, just rewrite this one like this and change the sign in front. That's all I did. I just rewrote this one to look like this and changed the sign in front. That's all you're doing. Okay. All right. So now common denominator, we're probably pretty good by now at finding common denominators. We've done quite a few of them like that. That's x plus 2 times x minus 2. And I'm going to multiply it to each term. Okay. And yeah, I could just write them in up here. But what I'm going to do, I'm just going to write it all out in case what I did before might have confused somebody. Okay, so let's just write it all out on this one. Okay, the video's already long enough. You've made it this far. It's not going to hurt to make it just a little bit longer. Ah, shoot. Let's see. Hang on, technical difficulties. All right, so hopefully we got it now. I have no idea what happened. OneNote crashed. All right. So we've got 3 over x plus 2 plus x plus 2 times x minus 2 times 4 over x minus 2. And this is all over x plus 2, x minus 2, 1 over x plus 2 minus x plus 2, x minus 2 times 3 over x minus 2. All right, so there we go. That's what it looks like when you write it all out. And like I said, yeah, you can write them in up here like this too. Okay, like I did in that previous problem. You could do that. Okay, that's fine. I just wanted to write it all out one time so you could see it. Okay. All right. So now let's see. This and this cancel. This and this cancel. This and this cancel. And this one cancel. So we're left with 3 times, let me change colors. So we're left with 3 times x minus 2 plus 4 times x plus 2 over, and that's going to be 1 times x minus 2 minus, and then 3 times x plus 2. Okay, see the 3 times x minus 2, the 4 times x plus 2, the 1 times x minus 2, and the 3 times x plus 2. And then I'm just going to clear parentheses, combine like terms. So that is going to be 3x minus 6 plus 4x plus 8 over x minus 2 minus 3x minus 6. Combine like terms, that's 7x plus 2 over, that's going to be negative 2x minus 8. And yes, we could factor out a negative 2. Is that going to make it cancel with anything up here? No, it's not going to make anything cancel, so we'll just leave it like that. All right. All right, so now last problem. All right, so we've got negative exponents here. And obviously, if you're at this point in college algebra, you've already worked with negative exponents, you know how to make them positive. So, if we had something like this, b over, I don't know, a, well, no, let's just do this. Let's say c to the negative 3 times d. If you had something like that, well, we know we could move this across the fraction bar, move this across the fraction bar, and that would change the sign of the exponents. And you can do that. So why not just move this a to the negative 1 across the fraction bar, this b to the negative 2 up, this down, and this a to the negative 4? Why not move those across the fraction bar like that? Because of that plus sign. That makes it to where you can't do that. They all have to be multiplied like this in order to do that. So what do? Well, let me show you. Look at each individual term. Look at that as being over 1. Look at that as being over 1. That one and that one. Look at each individual term as being a fraction. And then, see this? We can move it across that fraction bar. We can move it across that fraction bar. We can move it across. We can move it across. Remember, whenever you move something across the fraction bar, changes the sign of the exponent. Okay, that was one of the first videos I did, college algebra, integral exponents. Check that out if you need to watch it. And so that's going to be what? 1 over a, that's that term, plus 1 over b cubed divided by, that's going to be a over b squared, and this one is going to be plus b over a to the 4th. Okay, and now we've got a complex fraction. Now we simplify it just like we've done all the other ones. So get a common denominator. So my common denominator is a to the 4th b cubed. Well, how did you get the common denominator, you might be asking? Well, I look at all the different denominators. So let's look at the a's. Got an a to the 1st, a to the 4th. Remember, I told you earlier, the common denominator, when they're like that, it's the one with the larger exponent, a to the 4th. I got b squared, b cubed, one with the larger exponent, b cubed. And I'm going to multiply it to each term. And yes, if you wanted to, you could just write it in by each one. I'll leave that up to you. I mean, it saves time, but at the same time, you could make a careless mistake, doing it like that. writing it all out like this, I think it helps you see it a little better. So, you know, I don't know how many of you's getting that tip, because I don't know how many people have hung around to watch this much of the video. If you have, leave me a comment letting me know. All right. So we've got what? A and a to the fourth. That leaves me with a cubed. Here we got the b cubed and the b cubed cancel out. And then we've got b squared and b cubed cancel out. That leaves me with b squared. I'm sorry, not b squared. That leaves me with just b. And then a to the fourth and a to the fourth cancel out. So this is going to leave me with what? A cubed, b cubed. This one's going to leave me with a to the fourth. And this one, a to the fourth times a, is a to the fifth. No, and don't let me forget that a to the fifth b. Don't want to leave that out. If I do, I'll hear it in the comments. You don't know what you're doing. And then we got b cubed times b. That is b to the fourth. Okay. So hopefully all of that made sense. And yes, you can factor out the greatest common factor here, but nothing's going to cancel. This is going to be that's going to be your final answer. So I hope all that made sense. I hope I didn't make a careless mistake somewhere. If I did, just let me know in the comment. So check out my other videos. I hope you feel smarter now. Give me a like, share, and subscribe, and thanks for watching.